Good morning students. In today's video we are going to be covered these topics, that calculations based on weight relation, weight volume relation, volume relationship and Avogadro's law. Already in the previous session we have done with the mole concept, right, and we have what is the stoichiometry, what are stoichiometric calculations and how to balancing the balanced equation, what is the information we can get from the balanced equation and all, right. So in today's video we are going to cover with some calculations based on, in a chemical reaction is given, how to calculate based on the weight relationship, weight volume relationship, volume relationship and of the Avogadro's law, right. Okay, let us start our video today. See, so the first one is calculations based on weight relationship. So what is this weight relationship? In the previous session, so one chemical equation we can define like in the in presence of molecular representation, molar representation, weight representation and also volume representation, like we have done. Means if you have any one equation, 2CO plus O2 gives rise to 2CO2. If suppose this is the given chemical reaction, this one he is asking to calculate for the carbon dioxide. Means when 2 grams of carbon monoxide reacts with the oxygen, gives how much amount of carbon dioxide. So these are calculations based on weight relation, weight volume relation, volume relationship. Means see, these two are the reactants and this is the product. What is this weight volume relationship? Means see, when carbon monoxide in terms of weight he is asking and how much amount, means 2 grams of carbon monoxide reacts with 3 grams of oxygen, gives how much amount of carbon dioxide. All the reactants and products we are dealing with the in terms of weight, isn't it? That is called weight relationship between the reactants and the products. In between the reactants also we can calculate, in between the products also we can calculate, right. So suppose 2 grams of otherwise 2 grams of carbon monoxide reacts with oxygen, gives how much volume, how many liters of CO2 is producing, how many liters, means in terms of volume. So reactants information is giving in terms of weights, but he is asking to calculate the products information in terms of volume. So that is called weight volume relationship. Suppose if you take carbon monoxide in terms of volume, means suppose 3 liters of carbon monoxide is reacted with 2 liters of oxygen and produces how many liters of carbon dioxide. If they ask like this, all we are dealing with the volume. So this is said to be volume relationship, right. This is said to be volume relationship. So majorly here in stoichiometry, the relationship between the reactants and products and its stoichiometric calculations, we are dealing with 3 types. Weight relationship between the reactants and products, or in between reactants or in between the products. Weight volume relationship between the reactants, products, in between reactants and in between the products. That depends upon the question, which type of question he is asking, right. So like that only volume relationships also. So here this is the regarding calculations based on weight relationship. So this method of stoichiometry uses the any substance, means either reactant or product, in terms of weight and weight relationships. Okay, let us see, by taking one problem, let us calculate how to identify this weight relationship, right. See here the question given, how many grams of carbon, question is how many grams of carbon is needed to completely react with 20 grams of silicon dioxide. How many grams of carbon is needed to completely react with 20 grams of silicon dioxide, and here they given atomic weight of silicon, right. Silicon is 28 nano. Atomic weight of silicon is 28. So this is the equation, relation between the silicon dioxide and carbon they have given. Okay, let us see, I am rewriting the reaction here. SiO2 SiO2, okay, 1 minute. SiO2 plus 3 moles of carbon gives you silicon carbide plus 2 moles of carbon monoxide. This is the reaction. But in the given problem, what is the relation they are asking? How many grams of carbon is needed to completely react with 20 grams of silicon dioxide. So here he is asking, here it is the silicon dioxide and here it is the carbon. So he is asking the relation weight, how many grams of carbon is needed to completely react with 20 grams of silicon dioxide. So both weight relations only, that too not in between the reactants and products, he is asking between the two reactants. Okay, so before going to this, we need the actual, either the reaction is balanced or not, we have to check. How to check either the given reaction is balanced or not? The equal number of, means the number of atoms on reactant side should be equal to number of atoms on the products side. Let us see here, one silicon we have. Here we have one silicon. We have one silicon. In the products side also we have one silicon, and here we have two oxygens. In the reactant side, product side also we have two oxygens. Comes to the carbons, here we have three carbons. Here we have one carbon is here and two carbons are here, total three carbons. So the given reaction is the balanced equation. So I'll rewrite the question here. SiO2 plus 3C gives SiC plus 2CO, right? Okay, the relation between these two. So first to find out what is its original weight, means what is its molecular weight. Silicon dioxide, for one silicon it is 28, molecular weight of silicon it is 28, plus for one oxygen it is 16, for two oxygens it is 32. So 16 2s are 32. So what is the molecular weight of silicon dioxide here? 60 grams. So 60 grams of silicon dioxide reacting with, for one carbon it is 12 grams. Like that in the given equation we have it 3 carbons. So 12 3s are 36. So 36 grams. Means 60 grams of silicon dioxide reacts with 36 grams of carbon to produce one silicon carbide and 2 moles of carbon monoxide, that is. So 60 grams gives 36 grams. Then in the question, how many grams of carbon is needed to completely react with 20 grams of silicon dioxide? So for 60 grams they given 36 grams of carbon. For 60 grams of silicon dioxide it produces 36 grams of carbon. So our question, for 20 grams of silicon dioxide, how much amount of carbon is required? Suppose consider it as X, just a crisscross method, like, means in the lower classes we study one pencil cost is this much, so two pencils cost is how much, such type. 60 grams gives 36 grams of carbon, 20 grams of silicon dioxide produces how much amount needed, how much amount of the carbon. So just discuss, then X equal to 20 into 36, 20 into 36 by 60. 2 3s are 36, 3 1s are 3, 3 2s are, so 6 grams, 12. So 60, for 60 grams 36 grams is needed, for 20 grams only 12 grams is needed. Here you can see 23s are 60, like that only 36 by 3 also gives you 12. So this is the weight relationship. Like this we have to calculate the weight relationship calculations, right? Now come to the next one. So here it is clear, it is 12 grams of carbon is 12 grams of carbon is needed to completely react with 12 grams of silicon dioxide, right? Comes to the next question. Calculations based on weight volume relationship. Yes, in the previous one we have done with weight relationship. Now he is asking to calculate weight volume relationship. How to calculate weight volume means either the reactants or products, any one substance we are considering in terms of weight, another one he asked to calculate in terms of volume. So if they give if they ask to calculate in terms of volume means how to consider. In terms of weight means we have taken initially its molecular weight, initially its actual molecular weight. Like that only, when we are talking in terms of volume, the volume we should take at STP conditions. STP, standard temperature and pressure conditions. At STP, always the volume will be 22.4 liters. Always the volume will be 22.4 liters. Okay, let us see here. Volume of 1 mole of any gas will be 22.4 liters. That is what they given, right? So let us do one problem based on this also, then we will understand. Here one problem is given. The amount of calcium carbonate, the amount of calcium carbonate required for the liberation of 5.6 liters of CO2 at STP. So first of all, here they did not give any chemical reaction between the calcium carbonate and the carbon dioxide. So that reaction we have to write. So we know that calcium carbonate on decomposition gives carbon dioxide and calcium oxide. Let's write the relation between calcium carbonate and carbon dioxide. CaCO3 gives rise to CaO plus CO2. CaO plus CO2, and you have to check either this reaction is balanced or not. Okay, let us check the given reaction is balanced or not. See here, this side 1 calcium, and even on the product side we have 1 calcium. Calciums are balanced. On the reactant side 1 carbon we have. On the product side also we have 1 carbon. So the carbon is also balanced. On the reactant side we have 3 oxygens. On the products side 1 oxygen and here 2 oxygens. Total this side we have 3 oxygens. So oxygens also balanced. Though the overall the given reaction is a balanced chemical equation we have taken. So I will rewrite the reaction. CaCO3 gives rise to CaO plus CO2. Now read the question. The amount of CaCO3 required, amount of indicates the weight. The amount of CaCO3 required, that indicates the weight. CaCO3 required for the liberation of 5.6 liters of CO2. But here CO2, here the relation first of all between the reactant and the product. The relation between the reactant and the product means relation between the calcium carbonate and CO2, CaCO3 and CO2. Next, what is that relation? CaCO3 in terms of weight, carbon dioxide in terms of volume, right? So the amount of CaCO3 required for the liberation of 5.6 liters means we have to take first of all the initial volumes. Initial weight for calcium carbonate, initial volume for carbon dioxide. So what is calcium carbonate's molecular weight? For calcium 40. For 1 carbon it is 12. For 1 oxygen it is 16. Like that we have 3 oxygens, 16 3s are 48. So once if you count you will get 100. So the weight of calcium carbonate here it is 100 grams. It is at the STP conditions. So 100 grams of calcium carbonate produces how many liters? It is at STP initially only 1 volume of CO2. So 1 into 22.4 liters of CO2. It is liberating. 100 grams of calcium carbonate is liberating at STP 1 into 22.4 liters of CO2. Then 5.6 liters of CO2 requires how much amount of CaCO3 he is asking. So 5.6 liters requires how much amount of CaCO3? For 100 grams it is 22.4 liters. For 5.6 liters how much it is? Just crisscross. So X equal to, I will write here. So X equal to 100 into 5.6 by 22.4. So 5.6 22.4. So simply we can take it is as 56 by 22.4 22.4 into 100. Obviously we know how many times? 56 to 224. 4 times. 56 4s are 224. 4 into 100 means 25. So how many grams is required for 5.6? 25 grams of CaCO3 is required for 5.6 liters. 100 grams gives 22.4 liters. 25 grams gives 5.6 liters. 22.4 in fourth part is 5.6. Like that only 100 in fourth part is 25. If you can calculate even that like also. But original procedure to calculate weight volume relations is this. At STP first we have to consider, then what are the given values, according to that we have to calculate. Okay. This is the weight volume relationship calculation. Let us go for the next. See, calculations based on weight volume we have completed. Now calculations based on volume relations. So the first one is weight. So what we did? At STP it's actual molecular weights we have taken and then consider with the given weight. What is the second one we have done? Weight to volume. Initial weight we have taken, initially STP volume we have taken. So according to that from the given problem we have calculated. Here both relations are volume. So both we have to consider at STP, means at 22.4 liters like. Let us do one problem even with that, then you will understand better. See, this is the problem is given. Calculate the volume of hydrogen, required to combine with, calculate the volume of hydrogen required to combine with 4.44.8 ml of nitrogen, as in the formation of ammonia at STP. So calculate the volume of hydrogen he is asking. First of all, while reading this problem we should understand what is the relation between nitrogen, hydrogen and ammonia. We know that the Haber's process is nothing but nitrogen reacts with hydrogen and forms ammonia. That is Haber's process under some temperature and pressure conditions, right? So let us write that reaction here. N2 plus H2 gives rise to 3H2. Write the first reaction, N2 plus H2. Nitrogen and hydrogen reacts to form ammonia, means NH3. But you observe this is the relation, either this reaction is balanced or not, because all stoichiometric calculations we have to balance for do for balanced chemical reactions only. So check here either it is balanced or not. N2 plus H2 gives NH3. So here how many nitrogens we have? 2 nitrogens comes to here, but in the reactants side, in the products side we have only 1 nitrogen. So to balance that I am writing 2 here. We are not supposed to write 2 here. Why? Why? Because ammonia formula is always NH3 only. We are not supposed to disturb that NH3 molecular formula. So I will write here. Now these 2 belongs to nitrogen as well as hydrogens also. So nitrogens are balanced now. Come to the hydrogens. Here how many hydrogens we have? 2 hydrogens we have. Comes to the products, these 2 belongs to hydrogen also. So 2 3s are 6. This side 6 hydrogens are there, but in the reactant side only 2 hydrogens are there. So 3H2 gives rise to 2NH3. Now it is a balanced equation. For this now we have to calculate for the given data. Calculate the volume of hydrogen hydrogen required. Here hydrogen required for to combine with 44.8 ml of nitrogen as in the formation of ammonia at STP conditions. So here he is asking the relation between nitrogen and hydrogen, right? So let us start initially, means first take one reaction, then take the reaction clearly, then we will understand. N2 plus 3H2 gives rise to 2NH3. Here the relation is, he is asking for both nitrogen and hydrogen in terms of volumes only. So see here nitrogen, how many moles are there? Nothing is here, is nothing but 1 mole. So 1 mole of nitrogen reacts with, what is the number here? 3 moles. What is the number here? 3 moles. 1 mole of nitrogen reacts with 3 moles of hydrogen. That is nothing but 1 into 22.4 liters of nitrogen reacts with 3 into 22.4 liters, 3 into 22.4 liters of H2. But he is asking, so that is nothing but 22.4 liters of N2 gives 3 into 22.4 liters. But he is asking here 44.8 ml gives how much? 44.8 ml of nitrogen uses how much amount of hydrogen, right? So how to do this one? Simply crisscrossing. Let us think it is as x, then x equal to, then x equal to 44.8 into 3 into 22.4 by 22.4. These 22.4 get cancelled. Then if you multiply with 44.8 into 3, how much you will get? (134.4 liters). So for 22.4 liters of nitrogen produces 3 into 22.4 liters of hydrogen, then 44.8 liters produces 134.4 liters of hydrogen is required to produce the ammonia. So it is volume relation. While you are taking weight, you have to take the initial molecular weight. While you are talking about the volume, then you have to take the volume 22.4 liters at STP. Okay, this is the methods to calculate weight, volume relationships. Okay, the next one is, the next we have calculations based on volume also we have completed. The next one is Avogadro's law. Avogadro's law is very easy. What is this Avogadro? What is this law is indicating? Always this law we study at constant temperature and pressure conditions. So if you are keep constant the pressure and temperature conditions, means at room temperature you take, at room temperature pressure and at room conditions pressure and temperature is constant, then the volume of any gas or volume of any liquid is directly proportional to its number of molecules. That is nothing but, I will take 1 glass of water. That 1 glass of water means 100 ml. 100 ml of water I have taken. So I kept pressure and temperature conditions are constant. Means suppose think temperature is at 25 degrees Celsius and pressure is at some 2 atmosphere or 3 atmosphere. Suppose take that. Always that 100 ml of glass of water will contain the constant amount of water molecules. 100 ml contains always 20, suppose think 20 molecules. That there is no change in the water molecules. Always 100 ml of water will have 20 or X water molecules, it is constant unless and until we change the pressure and temperature conditions. Volume is directly proportional to small n. Volume is directly proportional to small n is nothing but the number of moles. V proportional to n means number of moles. V is nothing but volume and n is nothing but number of moles or number of molecules also we can take. So, this is what Avogadro's law. This suggestion by Avogadro explained beautifully by Gay-Lussac's. This is Gay-Lussac's law, like we will study later in the behavior of gases or like. Okay. So, this is about the Avogadro's law. At a constant temperature and pressure, volume of the given mass of the gas or volume of the any liquid, given mass of the liquid is directly proportional to the number of molecules or number of moles present in that gas. Always it will be same. This is called Avogadro's law. Okay. So, in today's class we have done with mole, in the mole concept and stoichiometry. Not only in today's class, the whole mole concept and stoichiometry we have gone through how to calculate mass percentages, empirical formula and molecular formula. So, molecular stoichiometry, how to deal with that chemical reactions, and weight relation, weight volume relation and volume relations. This is the mole concept and stoichiometry.